You'll have opportunities in your homework to practice. All right, so we've knocked out 12 of the things so far. We've got the 6 hyperbolic trig functions. We kind of have an idea what they look like, how they're defined. We now have their derivatives. We saw one example of how you could take a derivative with just one of them. And now we start on the inverse ones. So if we restrict the hyperbolic trig functions appropriately, right? And I'm actually not going to go into detail about how those restrictions need to be made. Like back in pre-cal, you needed to know all the proper restrictions on these. Here, we're just going to say, yes, there are restrictions. We can look in the book if we want to find them, but we don't need to like memorize them the way we had the other ones memorized. And in fact, where the heck did I only put 2 of them here? I said, oh, there it is. Oops, there it is. Okay. All right, so there are 3 here. Come on. There we go. Wow, look at that. The definition of the hyperbolic trig functions. So the inverse of the hyperbolic sine function is a natural log of some junk that looks pretty nasty, doesn't it? Why would it have a natural log in it? Because sine hyperbolic had e in it, right? So if you're going to undo it, you're probably going to need a log, right? So it makes sense to see logs here, doesn't it? All right. There they are. Ugly. Are those on your formula sheet? Definitions of those? That would probably be back on that reference page 4. They are there. Man, those reference pages, they're a good reference, aren't they? All right, so look, there's 3 of them here, okay? The other 3, I believe, are in the book, but they come up so infrequently that this is good enough, all right? And you might be wondering, like, where does this come from? That just seems crazy. I mean, like, you agreed with me that there should be a natural log there, but what's all this other crap in here, right? So my example that I'm going to do right now is I'm going to show you, well, I want us to show why this is this. And before I do this, let me kind of, prepare you for this. Sometimes we do problems in a class not because you're going to need to reproduce this or do it yourself. It's more like, there's a moral to the story. So I think when we finish this, we can talk about the moral of the story. So don't get too bogged down on like, I would have never seen that, or like, I would have never done that. I'm exposing you to this so that now you've got this. You've seen that sort of attack on something before, all right? Just kind of improving your experience. Now, I'm going to get to a point where I ask if anyone knows how to do something, and maybe someone will. I haven't had anyone within the last 5 years, haven't had anyone be able to get me past this one spot. So we'll see if anyone can do it. All right, first thing I'm going to do to try and figure out what this is I'm going to just be very clear on what it is I'm trying to do. All right, so I'm going to let y be equal to the inverse hyperbolic sine function of x. So I would like to know what y is, right? What is y? And at the end, I need to show you it's this, right? So let's just keep that in mind. We want to know what y is. We want to know what y is, right? The only thing that I have any information about is the hyperbolic sine function, not the inverse. The inverse I have no knowledge of right now. So what I'm going to do is I'm going to use the property that if this is the inverse function, then if I come in on both sides of this and I apply the sine hyperbolic function to both sides, if it behaves appropriately, like any inverse function should do when you compose it with its original function, right? Anytime you put the function with its inverse, then the right side should clean up real nice, shouldn't it? It should just be x. And the left side, well, it's sine hyperbolic y. So I've asked us to figure out what y is, And now we've gone through and we've trapped the y in a sine hyperbolic function. So it doesn't look like we're getting anywhere. But I know something about y. I mean sine hyperbolic. I know its definition. The definition of sine hyperbolic involves e's. So let's rewrite this. This is, left side is 1/2, help me out, e to the y. Now, so we have to be careful. What's the argument in here? It's y, not x this time. So e to the y, e to the negative y, like that. Close it off. I know that that must equal x. Okay. So far, so good? What are we trying to figure out again? What's y? Okay. There it is. And there's negative y. And we have an equation now, and you need to solve for y. So solve that for y. Okay, so logarithm, not differentiation. Logs are going to come into play somehow, right? Can we do a log right now? Will it help us? What do you think? Let me remind you of the property of logs that we could use. The natural log of e to junk, okay, doesn't matter what that is just the junk, right? The natural log and the e wipe each other out. Yes? But what about natural log of e to the y minus e to the negative y? Can I just do that? Can I distribute the natural log through? Absolutely not. There's nothing you can do. The only property we have with logs that allows you to do anything like that, like split it up, because natural log is not a number, right? It doesn't distribute like that. We have this property of natural logs. Natural log of x times y equals natural log x plus natural log y. We have that from college algebra. That's when you were doing condensing and expanding logarithmic expressions. Does that sound familiar? Where you'd like rip them apart or you'd push them all together. Powers would come down. 1414, college algebra. Yeah. So that property is good, but it requires multiplication inside here. And I don't have multiplication. So you're on the right track. We will need a log. We know we're going to need a log. It's just not yet. I need a single expression in E before I can bring a log in. All right, so this is where I've said the wheels start to come off a little bit. And I've had some students get me to the next couple of steps. But once I get to this one step, people don't know what to do. So I'm showing this to you because first time I saw it, I was like, wow, I had no idea I could do that. That's really cool. All right, anything. I'll take anything at this point. Just give me some algebra that's good right now. Multiply by 2. I like that. Okay, let's clear the half out. Multiply left side by 2. I'm just going to get e to the y minus e to the negative y. All right, that's good. Right side, 2x.
Can we use substitution?
Use substitution how? Tell me how.
We can make u e to the y.
You want to make u e to the y. All right, I have no problem with that because it will get you where I want you to go. But let me ask you now how I'm going to rewrite this then. How would it be rewritten?
It would be
u. Does everyone see that we're just going to replace every e to the y with u?
Mm-hmm.
Why are we doing that? I don't know. Because you wanted to do it, right? All right. Why did you want to do it?
It's just like whenever I run into these things, I usually do that.
Okay, so this is important. We need to have this discussion, all right? Instinct, right? Instinct is a big deal in this class. This is what I was trying to explain in the beginning. And if you watch the orientation video, I alluded to it a little bit. This course is difficult to teach because I can't teach instinct. Instinct comes from experience, and it comes from you really having built a solid foundation for yourself. In Cal 1, you worked hard. You did as many problems as you could. You didn't just barely squeeze through Cal 1. It wasn't one of those situations. I'm just being honest with you because I can't teach instinct. So this is the correct instinct to have. All right, let's continue. Yes? I'm willing to factor if we can, but I don't quite see where you're going to factor.
Then it would be like times 1 minus e to the negative 2y because when you add e to the y plus e to the negative 2y, it's e to the negative y. Do you know what I mean?
I'm not quite sure I'm following you.
So if you, so isn't that on the left side, wouldn't that be equivalent to e to the y, and then parentheses times 1 minus e to the negative 2y?
E to the y times in parentheses 1 minus e to the what?
Negative 2y?
Negative 2. You might have just answered your own question.
Well,
This is going to be u, right? This is going to be u. 1 minus now, how is this?
but don't, I mean, because when you,
She's saying if you multiply e to the y times e, yeah, that.
I agree that that's this, yes. I'm not disagreeing that this is, but my question is, are you still sticking with this or no? You're not, okay, I'm sorry. I thought you wanted this.
no,
Okay. And then from here, you could use the log and split it into two. But then when you get the log on this one, it's got separation with two things, and that's going to be a problem.
so is that, but isn't, so one might, you can just take the one away, is the other question.
No. So again, these are all good things, because there's a big danger in this class. If you're not willing to try something, then it's going to be a real. You almost got another point there. You almost got another point there. Look, I'm just trying to be real. I don't want to be a pessimist. I hate being a pessimist, but there's such a difference in what's required from you in this course. Like the effort is just so much higher than Cal 1. It's like night and day. And if you get to something like this and you completely shut down and you're not willing to try something, even if it's wrong, the class becomes very, very, very tough. You're going to fail 10 times before you get the problem right. That's the way it's going to be when we move on into the techniques of integration. You're going to try something, your instinct's going to be wrong, you're going to crumble it up, you're going to throw it away, and you're going to start over. And you're just going to keep doing that until your instincts start to kick in. Understand? That's why it's not product rule, quotient rule, chain rule. I am a machine. I can copy a formula and follow a pattern. It's not that. All right, so, sorry, I'm getting all off topic. I'm going to stick with the u, all right?
So it'd be u minus u to the negative 1.
Yeah, this right here would become u. The only tricky thing is that, so I'm going to rewrite this before we do it. This would be u, not u, I didn't mean to do that yet. It would be e to the y, and then minus 1 over e to the y. That's the same thing, equals 2x. I'm just going to try and make it look exactly like the u, all right? We good with that?
Yep.
Everyone agree that's the same thing? Okay, now let's replace all our e to the y's with u's. So I get u minus 1 over u equals 2x. Okay, so you want to clear fractions out, multiply everything by u both sides. That's good instinct. I'm okay with that. Y'all okay with that? So I multiply this by u, this by u, this by u. And I get u squared minus 1 2xu. What are we solving for? We have to be solving for u because u is in terms of y, right? So if we're ever going to get back to y, which was the original problem, we're going to have to solve for solve for u first. So I need to solve this for u.
Can you move over the 1 and then move over the 2x?
I can move, yes, so let me do this. We are now at the point that I have not seen anyone be able to do it, all right? We are now there. U squared, I'll write this however you want me to write it. Minus 2xu, you want me to do it that way? Minus 1 equals 0. Someone else wants me to write u squared minus 2xu equals 1. And I think that's probably the only things. Yes, is that good enough? Which one do you want me to go after first? I'll do the one on the right, because you're going to get stuck. So we can get that one out of the way. Factor out of u?
Yeah.
Okay, u minus 2x equals 1. Hold on, let's finish this one first. Can I do anything with that? Can I set u equal to 1 and u equal to this? U equal to 1 and this equal to 1?
Yes.
Can I? No. No, it has to be a 0. This has to be a 0. Okay? Look at what you're saying here. Let's just take a step back. Something times something is 1, right? If I tell you A times B is 1, does that mean that one of them has to be 1?
No.
No. Give me an example of two numbers that would multiply to be 1 where neither one of them is 1. 2 times a half. That's true? So this isn't 1 and this isn't 1, but they multiply to be 1. So when you have two things that multiply to be 1, that does not mean one of them has to be 1. Because 1 is not 0. It's called the zero factor property. Now if I change that to a 0, there is no way you're ever going to get 0 unless one of those is 0. You can try all day long for the rest of your life, and it's never going to happen. All right? And because of that, this isn't going to work. Good try, good instinct. Okay. Do you want to? Okay. Keep going. I'm
Can you expand?
with you, kind of.
Or no?
What's that?
Quadratic formula?
Quadratic formula, how do you mean?
Never mind.
Why?
I don't know, I just saw
Are we talking about this one or this one now?
that one.
Yeah, let's erase the other one. I don't want you thinking about that one anymore. How's my time? Oh my gosh. Okay. You're so close. But I've got a time crunch now.
That thing, chapter 12.
All right, so let me remind you of something. If we were in college algebra and we had any general quadratic equation, and this would be called a quadratic in x, because x is the variable, and a, b, and c are numbers, right? A, b, and c are what?
Number.
They're what?
Number.
Numbers, right? That's what we've always done, right? This is a number, this is a number, this is a number, equals 0, and we applied the formula, right? When we look over here, you kind of see that it looks like a quadratic in what? In u, right? Where the coefficients, the a is actually what? 1. The b is negative 2x, right? That's your b, and your c is negative 1. Do y'all follow me? I wonder if the quadratic formula would still work even though that's a variable. And the answer is yes. Okay? It'll still work. So all I'm going to do now is apply the quadratic formula to that quadratic in u using, instead of a, using 1, instead of b, using negative 2x, and instead of c, I'm going to use negative 1, right? And everyone knows the quadratic formula, right? This would be x is negative b squared minus 4ac all over 2a. That's our quadratic formula. Okay, let's start plugging in. So I'm not going to write x, right? I'm going to write u is equal to negative b, which for us would be, it's minus 2x already, right? So when I make it negative, it's going to be 2x plus or minus square root b squared. So, right, that's a, that's b, that's c, right? So b squared is negative 2x, that quantity squared, which would be 4x squared. Minus 4 times a times c, right? All over 2 times 1, right? Everyone see that? All right. What is this right here? These three guys right there. It's positive 4. So I get 2x plus or minus square root 4x squared, what?
Minus, or sorry, plus 4.
Plus 4. Can I write it this way? No, I did that for a reason, because 4 is a perfect square, and it's going to come out of that root, right? And then once it comes out of this root, it's going to be a 2 right there. And now this has a 2, this has a 2, and this has a 2, which means all the 2's go away, which leaves me with what? X. Ooh, we are getting close. We are getting close, right? We are getting close. But yeah, we're going to have to deal with why it's plus and not the minus. But remember, this is u, right?
Yeah.
Okay, so let me write that